Okay, I will start telling you the exam format. First of all, there's MCQ, 5 MCQ, which is 10 mark there. Then usually the B1 is a mensuration. Find the parameter, find the area, okay, all this surface area, volume, and so on. And usually this is around about 16 mark, and usually it's a 2D problem. Okay, so usually it's a two-dimensional object here rather than 3D object here. So you know how to make sure that you understand all the circle, square, okay, 2D object, how to find all these things formula. Then B2 usually is the graph of straight line, quadratic curve. Okay, you have draw graph. I think this is around 12 mark there. Then B3 is polar coordinates and conics. So as we need part A, part B, okay, polar coordinates is one part, and then the polar coordinate. Then B4 is bearing question, easy bearing question. Okay, then just draw a triangle and then figure out what is all the angle, distance, and this thing, angle, elevation, including angle, elevation. Okay, and this sort of thing. All right. Then the spherical triangle, Napier's rule, this is on B5. And B6 is a big question. Okay, or you apply all the sine law and cosine law, spherical sine law, spherical cosine law to solve the spherical circle. So these are the basically what you expect from the exam. Okay, so I think I yesterday WhatsApp to you B1 and B2 really. So I'm going to start off with B3, right? Polar coordinate first, and then conic, I change the question. So I'm going to look at polar coordinate first. So let's do the question. This is the question of polar coordinate here. So I just erase this one first. Okay, I just copy the question and do again. Okay, so I'm going to do polar coordinate first. So convert the rectangular coordinate 5, 9 into polar coordinate xy. So this one, you all must know how to do this. Rectangular coordinate 5, 9. What does it mean? So you have x equal to 5, y equal to 9. Okay, rectangular coordinate is x and y now. How to find polar coordinate then? You draw a point. Right? Where is 5, 9? So 5, 9 is actually here. This is 5 here, and 9 somewhere here. So 5 somewhere here, 5 and 9. So locate the point 5, 9. So this is 5, 9 here. Okay, and then you will find out what is r and theta here. R is always measured from origin. Theta is the angle measured from the positive x-axis. This is what we mean. So how to find r and theta now? So r is equal to square root of x squared plus y squared. Okay, using right angle triangle, you find that okay, this is y here, this is x here. So 5, 9. So this is 9 here. So you get square root of 5 square plus 9 square. This is 25 plus 81. Then calculate what is this R here. So 25 plus 81. Okay, 106. And so this is actually take a square root of 106 now. Square root of answer is actually 10.29, 10.3. So the distance from the origin is 10.3. Okay, R is 10.3. And then how to find the angle now? Okay, use the formula. Okay, tangent theta is equal to y over x. Okay, y is equal to 9, x is equal to 5. So theta is equal to tangent inverse 9 over 5. So find out, okay, what is tangent inverse 9 over 5? So tangent inverse 1 over 5 is a shift. Tangent inverse, put 9 over 5 here, so 9 over 5. And then is 60.9. So this is how to answer part A. If you know how to do this, you get 4 marks. Okay, so usually this is a 4-mark question for part A. So standard formula, remember the step, and you can get an answer of R and theta. Okay, R is this case, so R is equal to 10.3, theta is equal to 60.9. Right? So okay, R and theta, this is what to do in the polar coordinate. Okay, polar coordinate is R and theta. So this is part A. Then part B. So again, insert a new page here. Then part B now, same thing. Now you have polar coordinate, convert to rectangular coordinate now. So what does it mean? Okay, the first number is always R. So R is equal to 3. Theta equal to 106. So you draw the point. Where is it now? So let me use the dark color one. So R from origin is 3. Distance is 3. Theta is 106. So this is 0 here, this is 90. The one is 0. So just want to get a straight line. Okay, so 0 here, this one is 0 now. So it tells you that the distance from origin is 3. Direction is 106. Direction 106 means you go here, 106 now, somewhere here, more than 90 degrees, right? 106 here, direction 106. And distance from origin is, you know direction already, so you got this direction, okay, and the distance is 3. Okay, R equal 3. Okay, this is the point. 3, 106. Right, theta is 106 here. R equal 3. So now I want to find out what is xy. Okay, rectangular coordinate with xy. That means What is x and y now? Okay, this one you memorize the formula. You just take the x equal to r cosine theta always, y equal to r sine theta. Okay, memorize this formula here. So memorize. Same thing. If you cannot remember, then you memorize, right? Also, same thing here. This one also memorize r and theta. So you get x equal to r cosine theta, r equal to 3 now, cosine 106. So 3 times cosine 106, 1 is what now? So you get 3 times cosine 106 degree. You see the number is negative now, minus 0.82. The y will be positive now, sine 106 here. When you draw a diagram, you know the value is positive, negative value, right? So 3 sine 106 now. And this 2.8 here. Okay, so the rectangular coordinate is x and y. So xy is equal to minus 0.82 and y is equal to 2.8. Right? So this is actually how you answer part A and B for B3. So let's see how many are you are here now. I think only 8 of you, including myself. Okay, so I will just WhatsApp this thing to you first. Okay, so this is 2 right? Yeah. So let me WhatsApp this part first to you first. So yeah, so I will go back to this one, B3A. So I should talk about the exam format first. So that is both important here, so that you know what to expect in the exam. So just now I mentioned about exam format. So this is important, so you will help you prepare exam format first. Okay, then the B3A, right? So B3A, okay, B3A first. How to do this type of question? Okay, B3A and then B3B. Okay. Okay, so if you look at the question I have listed out from B1 and B6, right? So yeah, MCQ really 10 mark, observation 16 mark, 26 mark, graph 12 mark, and then 26 mark by 12, about 38, right? Then polar coordinate, and then this one is 8 mark here. Okay, let's look at coordinate. Now, coordinate is also inside there, but the practice exam, the coordinate is a hyperbola, but we actually has the coordinate will be ellipse. Okay, it's always ellipse here. So this is the question. So this is not in the practice exam because I changed the question there already. So this is part C now. So you always do something like this. Okay, ellipse. So you know it's going to be ellipse in the exam. Okay, let's see what the question is about, right? Ellipse are help you recall the ellipse question here. The diagram below show a boat P. P is a boat now. Travel around the ellipse boundary of a lake, which has a length major axis AB 300 meter. Okay, major axis 300 meter here from A to B, which is from east to west. And the length of minor axis 200 there. CD, right? From north to south. With the center origin. Write down a few things, okay? First down, what is the standard equation of ellipse here? Okay, how to find equation of ellipse here? So ellipse looks something like this. With a center origin, part 1, right? Solve it like this. X squared over A squared plus Y squared over B squared equal to 1. This is the equation of ellipse, right? Standard equation of ellipse. So this is why it's called standard. There are many forms of equation, but we will look at a standard equation of ellipse here. Part 1. So what is A and B now? Okay, A is the 200, right? So AB axis is a major axis is 300 here. So AB is actually 300. The length of major axis is 300 here. The length of minor axis is 200 here. So let's check the notes again, right? So if you look at the notes about the conic one, okay, at A and B, so that you make sure that you actually use the correct formula. Okay, the conic. Okay, so A is this actually called 2A. The length of major axis is 2A here. The length of major minor axis is 2B, right? So look at the formula. Okay, the formula in sometimes remember which one is A versus B, right? So this one is actually A. So the length is 2A. This is actually B. So the length is 2B, right? So A is equal to 150 now, and B is equal to 100 now. The minor axis here. So this one you have to look at the formula. If inside this is actually, if you look at notes there, page 312. Okay, in the notes, it's page 312. The diagram. Right? Which one is A, which one is B? So that means that you put it in, you got the equation of ellipse. Standard equation is x squared over 150 squared plus y squared over 100 squared equal to 1. Okay, this is how you answer part 1 of equation of ellipse here. You know, in the exam, we have test you ellipse. So at least you must know how the equation of ellipse look like. So this question, you have a few things. One of them is major axis, length of major axis is 2a. Is 2a now. AB, right, is 2a. And then CD is 2b. And this information given to you. Now, length of F1P and F2P. So I'm going to redraw this diagram again to show you because I don't want me to counter here. So, okay, this is part 1 first. So let's WhatsApp this part 1 to you first. So this question is not in the practice exam. Okay, I replace the question in practice exam by this one because you need to know how to do question on ellipse. Okay, you have to know question on ellipse here. Okay, then I want to copy this question and then part 2, right? So edit selection 2, copy this question part 2. Okay, the length F1P and F2P add together, what is this equal to? This is a standard formula, right? The length F1P, where is this now? F1P is this one. F1P and F2P. So you can draw it here. What is the length of this one? I use different color. So F1P, F2P. Okay, F1P, F2P. Add together, what is this? Standard. F1P plus F2P. Add together is always equal to 2a. Okay, look at ellipse question, and then this is actually F1P, F2P is equal to 2a. And this is page 311, sorry, page 312 in the notes. So it's a memorized one. If you, so this one I memorize this. Okay, so this one memorize here. Okay, memorize. Now what's and the diagram as well. Where's A and B? Okay, so this one I memorize. Where's A and B? So let me erase this one and pass it to you first. Okay, just now I think it's not good reminder. So this is a good reminder here because tell you what to memorize. Okay, so now then we're going to do part B now. Okay, part B I have this one. F1P by F2P, what is this equal to? It's always 2a. 2a, where is 2a now? 2a is the length of major axis. So this distance here, from here to here, is 2a. Okay, which is AB, right? It's actually 300 here. So that means that this is actually 2a, it's actually 300 now. Okay, so this is how you know the length. And this one sure will test you, okay? And they'll ask you the equation of ellipse, then the length, right? So this is the page 12 of the notes there, memorize. because these are so easy question. Just one line, you answer already. Tells you whether you know this or don't know this. So this is how to find the part B, second part here. So let me present this to you. All right, then the third part, okay, one part, one question here. So edit, select 2 again. So I'm going to answer part C now. Part C, what is it all about? Oh, good. Okay, this one part C now. I just insert the page first. Okay, I want to find the length of F1, F2. Okay, the length of F1, F2. How to do this? F1, F2, the center to the F1, this distance is called C. Okay, C is equal to 0 to F1. Okay, C is equal to 0 to F1. Now, how do you find C here? Okay, this one again on page 312. Okay, on page 312. Okay, there's called the number C there. Now, C squared is equal to A squared minus B squared. Distance from origin to center, right? C is a distance from center to focus. Okay, distance from center to focus is called C here, and the formula for this thing is C squared equal A squared minus B squared. Okay, you only know what is A now, so this distance is A here. From here to here is A. For the vertex here is A. So this is the vertex here, and distance from here to here is B. So A is equal to 150, right? So this is 2A major axis. So this is called 2A here. 2A. This part is 2A. Okay. And then this part is 2B here. Okay, this is 2B here. So repeat again. Right? Length of major axis is 2A. So A is equal to, again, is 150 now. So 2A is 300. A is 150, right? We know just now. 2B is 200 here. So B is 100 here. So you find that C square is equal to 150 square minus 100 square. And then you find out what is this thing. Okay, the information, the formula is on page 312. Okay, so then you have 150 square minus 100 square, and 12500, and then you take a square root. Okay, 125. Let me use the color again. 12500. So C is equal to square root of 12500 now. So take the square root of this answer is equal to 111.8. So C is 111.8, but C is not the answer. Okay, C is not answer, right? Why? Because this C is a distance from origin to F1. I want distance between F1 and F2. Why is it now? The length of F1 F2 is what now? Is 2 times of this. Okay, 2 times of 111. Okay, 2 times of C now. So 2 times of C. So you get 2 times of C essentially, right? For F1 or F2. This one is 111.80 times 2 here. And 223.6. Okay, 224 lah. 224 meter. Okay, this is how to answer part 3. Part 3 of question 3C, right? So I have WhatsApp this to you first. So I have finished B3 for you already. Right, B3. I'll do this video. So you look at the exam format. I have tell you. Okay, the B1 I did for you already. B2 I did for you. B3 also I did for you already. So okay, now we're gonna do B4. B4 is bearing and angle elevation question, about 16 mark there, right? Bearing question. So I think the B4 in, okay, just pick one question to tell you how to do this. Okay, B4. Okay, you will see whether I can do this. I will try to give you a simple question, not so complicated one. Okay, but this exam is more complicated. I can WhatsApp to you the B4 solution. Okay, let me try the simpler one. Okay, I don't want to take this B4. Okay, so ignore this one. Okay, this is not difficult. I can show you the video. I can WhatsApp you a video. B4A got video. So I don't need to worry about this one. I don't know how to do this. Okay, gonna B4B now. Okay, so what I'm going to do is pick another question B4. Okay, which is simpler to do and less complicated, right? You don't expect to pick a simple question. All right, I'm going to pick one question from past year exam paper so that you have a pattern of how to do this. Okay, I have picked a question first. Okay, I'm going to also pick up the question of you pick. Okay, you can see the B4, but not in the practice question. I pick a past year exam paper to help you. Okay, the question are more straightforward. So let me copy again. Okay, don't go here, this one is too big. So this one is a simple triangle. So it help you a little bit here to draw a triangle for you. You remember the bearing question, usually you have to draw a triangle yourself. Then sometimes you don't know how to draw a triangle, you make all the mistake here. So they give you a simple diagram with a triangle draw for you already. So don't need to worry so much. So at least you get triangle there, right? So the diagram show you the position of each three building in a town. The bearing of the hospital from the arc gallery is 0.072, right? 72 degrees for arc gallery. You can see from the diagram. So usually I will try to set the question so that you don't need to draw a triangle. Okay, they draw a triangle for you already so that you don't need to worry about at least triangle how it look like. Right? Okay. The similar is due east of the hospital. So you see a similar there on the east side of the hospital. East means from the north go to 90 degrees, right? And then the distance for hospital and then gallery equal to the distance from the hospital to cinema. So these two distances are equal. I tell you that, right? What is the bearing of cinema from art gallery? Okay, I want the bearing of cinema from art gallery. What does it mean? Okay, first part. What they are looking for is basically this angle. Okay, answer for part A. What is the bearing of cinema from art gallery? So do you know the angle? Okay, if you draw carefully, okay, let's see how I get it out. So, you know, if you draw this 90 degree, okay, let me draw it first, 90 degree first. So this angle, I don't know, from here, this one is actually 72, right? From the diagram, because it's a parallel line north, right? So this one is 72. So that means that this is 72, right? So you draw it. This is 72. I know that this one is 90. So the angle at H now, you can find that angle at H here, hospital there, angle at H is 90 or 72. Alright, so because a parallel line, right? Because a parallel line, so you know that is 72 here. Okay, it's 72 here. What happened? Right. So that means that 90 plus 72, you get 90 plus 72, you get 162. Okay, so if you know that 162, then where is the angle and arc gallery now? So take away the rest of angle. 180 minus 162, you get okay, minus 180 there, get 18. So if you know that this 18 divided by 2 now, you know what is this angle now? This angle will be same length, like this, because this angle and this angle are the same. So angle at sigma and angle at arc gallery are actually 9 degree now, because left 18 degree divided by 2, we get 9 degree. Okay, so you know that this 9 degree now. So the bearing of cinema or arc gallery now. So bearing of cinema from arc gallery is 72 plus 9, right? So this is actually 81 degree. So this is actually how do you actually do some bearing question. I will not try to disclose too much here, so that you know the bearing question. I always draw a triangle for you, so that you don't need to worry triangle, and then you just work on that triangle, right? So this is our bearing question. Of course, they can ask you about distance, all these things, okay? How to find the distance between 2 points. Because there are no information until I give you more information. So that you just read the question along the line. You can actually read the question along the line, right? So this actually one. The question will actually slowly disclose to you what are the information you need, and you can just work on it. Okay, so this is actually about B4, right? So I will not try to disclose too much to you, because I think this is very sensitive now. Okay, at least you know, okay, in a bearing question, and then usually they also have elevation, right? Because we are building height, of course, you get elevation. Okay, then B5 usually is bigger triangle, Napier's rule. Okay, let's try to do something on B5. Let's see whether this question looks like Napier's rule, because okay, so I need to pick one question on Napier's rule for you to show you how to do Napier's rule. Because usually there will be Napier's rule. Okay, Napier's rule deal with right angle triangle, right? So I have one question Napier's rule now. Simple question. So Napier's rule, everyone must know, right? There's right angle triangles. So this is on Napier's rule. Sometimes also sine law and cosine law. Okay, simple sine law and cosine law. Okay, so I'll just use the Napier's rule as an example. So here a triangle, angle C is ABC, right? ABC. So the bigger triangle now, there's actually draw a triangle. So let's say this is C now. So A, B, C here. So this is 90 degrees at C. Side A. Side A is 73 degrees. All the length are measured in degree now. So side A is 73 degrees. Side B is 62 degrees. And find side C. Let's see this one. 10-mark question. Epso. How to draw it? Epso? Still remember? Okay. So this one you must remember how to draw Epso. Of course, we give you a formula. Okay. Epso divide the top into 2 parts, bottom into 3 parts. Okay. Then you can go according to clockwise and clockwise, doesn't matter. So you get 90 degrees. Okay, let's see, go this way. So you have a 90 degrees as the center, C, 90 degrees, right? So if you go by that, the next thing you're going to get is the side B. Then angle A. Then side C. Then angle B. Then side A. So depending on how you go, you can clockwise and clockwise or anti-clockwise, up to you. So I get Napier's view. Okay, how to draw Napier's view? You start from 90 degrees at the center. Okay, this is where you start from. Then you call clockwise and anti-clockwise. Go the side, angle side, right? So you know A is 73. So this is 73 here. And then B is 62. And you want to find side C. So how to do side C here? This is something we learned before. How to do this? The comb there. So I think I have forgotten Napier's way so long already. So you can better check the Napier's rule formula. So Napier's rule formula is actually, this is about C is opposite of A and B, right? Okay, C is opposite A and B. So you can use it. So sine of middle part of, okay, Napier's rule say sine of middle part is equal to product of cosine opposite. All this formula will be provided. We just have to use it. Okay, provided in the formula card, formula sheet. Okay, cosine opposite. So actually, it give you a lot of hint, right? Sine of middle part. So middle part is actually C there, but you have comb there. So that means that. So then you have to quite well versed of interchanging this. Okay. So sine of middle part, but this one is have a comb there. So that means it's cosine now. Okay, with comb. Okay, so sine of comb C. Okay, sine of column C is equal to product of cosine opposite. So cosine of A, cosine of B, and cosine opposite, because these are actually opposite of C is opposite A, right? Now cosine of column C, the sine of column C actually is cosine of C. Okay, and this is the cosine of A, which is actually 73 degree. Cosine of B, 62 degree. So the Napier's rule formula, there are two. One of them is product of cosine, one of them is product of tangent. Okay, tangent is for adjacent. Okay, the two formula, product of cosine opposite, product of tangent of adjacent. Okay, so these are the two possible formula for Napier's rule. I just picked Napier's rule because most likely there will be a Napier's rule. Okay, so now we check what is side C now. So I find cosine of 73 degree times cosine of 62 degree okay, then find out what is this thing. Okay, this is 0.13. So the side C is equal to cosine inverse of 0.13726, right? So cosine inverse now. So shift cosine inverse. Answer 82.11. Okay, so that means this side here is actually 82.11 degree. Okay, this is how you do a simple Napier's rule. Okay, so this is a simple Napier's rule. I will WhatsApp this to you. Okay, so I change the question B5 already. Okay, try again. All right, then we finally come to the last question of this paper. Okay, so I try to last question of this paper, right? Let me change the sharing now. I want to pick the sharing here. Okay, the B6 come out here. Okay, B6 is a big question. So by looking at the marks, you know that this is going to be a big question here. So, all right, so I'm going to go up to the question first. Okay, I'm going to share this question, right? So B6, because I worked out already, quite a big question. So I'm going to share this one. B6. Yeah, this one. Okay. Let's look at the question. Very short question, but the working is quite long. So I have, I think, write down the solution in 5 or 6 pages and to show the each part here. Okay, let's look at Let's try to figure out the question. The ship sails eastward. So the important is look at the sail from the east side, right? Sail to the east side here. Along the great circle from the point A to point B. Okay, so actually the ship sails from point to point. So you're going to form a triangle. Okay, how do you draw a triangle? You actually set up a point called the North Pole. North Pole usually called P. So you can see that, okay, and ship from sail from A to B. So you know the position, which one is higher, 20° north and 40° north. So 40° north is higher, right? So this is 40° north here. So I forgot to write down. So this is 40° north. Okay, this one is 40° north. So from A to B, and from 70 west to 50 west. Okay, so both from west to east, right? So you have a North Pole. So draw a spherical triangle with P as a North Pole. So that this is actually going east. First, draw a triangle first. Okay, first step. So let me WhatsApp to you because so that you can slowly follow. Okay, no go here. Let me try. I will move this on top here. Okay, this from B6, right? First, how to draw a triangle first to start. Okay, so okay, this is part A. Now, do you know what is PA? Do you know what is PB? Okay, PA and PB now. Let's try to find out what is PA here. First of all, what is the difference of angle between as you move from North Pole? So one of them, we look at the angle difference, right? From west to east. So this angle P, this is 70 to 50, right? The difference is 20. So this is the difference is longitude, this angle P here. Okay, different longitude actually this, okay, 70 and 50, so the difference is 20, right? So this way how you figure out the angle P for the North Pole. Okay, so how you figure out angle P for North Pole here. So let me WhatsApp to you one step at a time. Okay, let's see what's that. Page 2, right? So I find out after draw a triangle, I find that I can find out the angle difference P now. This angle difference is P help you to find the spherical triangle, especially the side, the distance. All right. So I now find PA. The North Pole is 90° north, right? So what is actually PA now? The angle between North Pole and A. Okay, the angle between North Pole and A is 70. Okay, North Pole is 90° north. A is 20° north. So difference between the angle the distance now, because this is how you measure the distance between 2 points, or by degree now, the different angle, 70 now. And also the difference between the angle PB now is 50, right? 90 minus 40, 50. So you know the side PA is 40, oh sorry, PA is 70, PB is 50. Okay, so this is what's up to you again. So I know page 3 now, PA and PB now. Okay, if you know that, I can start with part A now, right? Quick consider distance between A and B. What is the distance between A and B now? So straight away you can think of law of cosine. But it's a spherical law of cosine now, no? Okay, spherical law of cosine. Okay, how to do that? So law of cosine. Okay, this is a law of cosine formula. Okay, for spherical triangle. So this formula, okay, in the formula card, but I show law of cosine formula, and I'll show you what is the page number here. Okay, in case you don't know. Okay, law of cosine formula. Given two sides of an angle, you can find out what is the length AB now. So this law of cosine formula is actually given to you in a few places. So, okay, this is a page 210. Okay, law of cosine formula is page 210. You want to find out is page 210. So the formula directly, law of cosine formula is cosine P. Okay, cosine P, which is 20. Cosine P, actually the P is actually the not the angle, no? It's the side AB, no? Cosine P. So the P, I especially use a red color one. The cosine P is the length side, right? Because the other one I use capital letter for angle. So cosine P equal to cosine A cosine B. Okay, plus sine A sine B, then cosine of angle P. So this is you do it a few times, you can remember the formula. Okay, so this is how you use the cosine. Anyway, this formula also is in the formula sheet, so use it there. So this will be equal to 26 degree 20 minutes. Okay, the spherical cosine law given to you also in the formula card here. So this is how you find part A. Okay, so part A, the quick distance is actually 26 degree 20 minutes or 26 degree 33 minutes. Yeah. Okay, so this is part A. Okay, after I find part A already, okay, I do one step at a time. Now I do part B. Calculate the initial cost at the point A. What does it mean by initial cost? Cost basically is a bearing. Okay, initial cost. Okay, but part A not finished yet because I want to find the distance in nautical miles. Okay, how to find nautical miles? 1 degree is a 60 nautical miles conversion. Okay, so this one to memorize. 1 degree is 60 nautical miles. So the distance is now times 60. Okay, 26.23 times 60. So this one you have to memorize. If you memorize this, 1 degree is 60 nautical miles. okay? When you measure the distance on the Earth, this is 1 degree is 60 nautical miles. So you multiply this one, then you can convert to distance into nautical miles. So this is just part A only. And so quite long because I split them up into various parts. Okay, now I'm calculating cost, initial cost of A. So what does it mean initial cost of A? Okay, basically it's bearing now, bearing from A to B. Okay, bearing from A to B. So this time we have to use the sine law. Okay, use the sine law usually. So sine of A over angle A equal to sine of, you want the angle, right? So P, sine of P over angle P, which is 20 degrees. So I use the sine law to find out the angle A. So angle A in this case, after I find angle A 0.5906, I know find out what is A now. We find that it's bearing from B to A. From A, the bearing from B from A is called the initial cost. Because the North Pole, you can see that this is the North Pole, okay? This is the line going to north. Okay, so the bearing actually the angle from the north measure there. So this is how you get the initial cost. So I have used a sine law. Okay, again use sine law, but you can also use a cosine law. Okay, cosine law is a better answer. Okay, you can also use cosine law, right, to find the angle B. Okay, prefer to use, prefer to use law of cosine. Okay, in this case I use a sine law, but actually most people prefer use the law of cosine, because when you use the sine law, usually there are two possible answers, and then you have to check the answer which one is correct. But if you use the law of cosine, they always give you one answer, and that is the only answer. Okay, so just a side note here. So this basics here. Okay, last one, I think page almost finished already. The second part, final cost of B. Okay, what is final cost of B? What does it mean? Okay, final cost of B. That's why I use a sine law. Okay, cosine law here. So what is final cost of B? So the ship continue to move this way, right? Continue to move this way. So what is the bearing now for the North Pole? So the final cost is that the angle. The final cost is this angle here. Okay, the final cost is actually this angle. But you need to find out what is angle B first. Okay, you need to find out what is angle B first. So you can use the law of cosine to find angle B. So law of cosine to find angle B first. And the angles happen to be 133. Okay, that's why people like cosine law, because whatever you get, the cosine law give you one answer, and that is the correct answer. There's angle B inside the triangle. Okay, once you know the angle B inside triangle, then what is the bearing now? You just take 180 minus 134 in this case. in 46 degrees. So the bearing of the ship, the final course is north 46 east. Okay, from north 46 east, because the final is 46, right? The true bearing now, north 46 east. And this is the final course. So I accept this to you. So altogether, I show you that how to use the cosine law in this case. Actually, you can use cosine law all the way. Okay. Okay, so I finished all the 6 questions for you. Next week I can continue the rule revision for you. So if I miss this, there is next week again. Then last week only. So stop recording.